Alright, I'm going to talk to you about how to simplify radicals. And when you're simplifying radicals, the idea is that you want to get rid of any perfect squares that are inside the radical. It's kind of like simplifying fractions. You want to simplify it as much as you can. And so there's two properties that I want you to be aware of and make sure that you're going to use when you are simplifying radicals. And the first one is property of products, and what that is if you have the square root of a times b, I can break that up, and that's the same thing as the square root of a times the square root of b. So like if you have the square root of 2 times 3, that's the same thing as finding the square root of 2 times the square root of 3. Sorry, that's kind of hard to read. Then there's property of quotients. The square root of a over b is the same thing as the square root of a over the square root of b. So if you have the square root of 2 over 3, that's the same thing as the square root of 2 over the square root of 3. Now for this example here, let me highlight it. For this example here, and for this example here, there really isn't anything else you could do because there's not perfect squares there. But if there are perfect squares, you want to simplify them. You want to get them out of the radical symbol, or out of the radicand. This is called a radical symbol. Everything that's underneath it is called the radicand. Okay? All right, so let's start with the square root of 8. Now you can think of it as you're finding the perfect squares, and you could just keep kind of pulling out. Like I know that 8 is the same thing as square root of 4 times square root of 2. And I know that because 4 times 2 is equal to 8. And it works out nicely because the square root of 4 is a perfect square, and I can simplify that to 2. I cannot simplify square root of 2, so that stays the same. So square root of 8 is the same thing as 2 square root of 2. This problem, it's not so difficult, but sometimes when you have larger numbers, it's hard to make sure that you didn't miss any of the perfect squares. And by the perfect squares, I mean if I have, you have 1 squared, which is equal to 1. You have 2 squared, which is equal to 4. You have 3 squared, which is equal to 9. 4 squared, which is equal to 16. 5 squared, which is equal to 25. And I could keep going, but these are your perfect squares, meaning it's easy to find the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. It's easy when you have, if you know those perfect squares, whether they are factors of the radicand. But sometimes when you have, so like I said, sometimes when you have larger numbers, it's harder to pull out those perfect squares. So you can always do this. You can just pull out numbers until you simplify it as much as you can. And I know square root of 2, there's nothing else that goes into 2, so I can't simplify this anymore. But like I said, when you have larger numbers, it gets a little bit more difficult. So another strategy is to do prime factorization, just like you did in elementary school, okay? So you start off, so we've got 125. And again, I apologize for that writing. So we're going to pick two numbers and multiply that equal 25. So I know that 25 times 5 is equal to 125. 5 is prime, so I circle it. I don't need to break that down anymore. 25 is equal to 5 times 5. Those are both done, so I circle them and I'm done. So when we used to do prime factorization, we would say, well, the prime factorization of 125 is 5 times 5 times 5, because 5 times 5 times 5, or 5 cubed, is equal to 125. Well, the way we're going to use that here is I'm going to rewrite it as finding the square root of 5 times 5 times 5. And again, 5 times 5 times 5 is 125. Well, and the way I showed you guys in class is you want to look for pairs. I'm going to look for a pair here, and I have a pair of 5s. And so what I'm going to do is I'm going to pull that pair out. They're getting married, they're moving out of the house, okay? And so when they do that, this becomes, because I'm moving that pair out, they get married, they become 1 outside the house, and then that still leaves me with this 5 in here. So the answer, 125, simplifies to 5 square root of 5. And I know some of you may be looking, well, why were you able to do that? Well, if you look at, let me change my colors again. If if you're looking at square root of 5 times 5 times 5, that's the same thing as square root of 5 times square root of 5 times square root of 5. Well, square root of 5 times square root of 5, if I combine them together, that's the square root of 25. Well, square root of 25 is 5, and then I'm left with square root of 5 right here. So that's another way to kind of, so you can see why I was able to pull that out. Because when you have two numbers multiplied, the square root of those two numbers is one of those numbers, and so that's why you're able to pull that out and put it outside the radical. And if you want to check your answer just to make sure that you did it right, you square a number to put it back under here. So 5 squared is 25, and then 25 times 5 is 125. So that's how I know that I did it right. All right, let's try 3 square root of 27. Again, I'm going to start by finding the prime factorization of 27, and that's going to be, let's see, we've got 3 times 9. 3 is prime, so I circle it, and 9 is equal to 3 times 3. I circle them. So that means that the 3 square root of 27 is equal to 3 times the square root of 3 times 3 times 3. Well, I want to pull out my couples so they can get married and move out of the house. So when I do that, I'm going to pull one of these 3's out. I already have this 3 outside, right? That's what this 3 is right here. I'm pulling one of these 3's out so they move outside the house. Then that leaves me with the square root of 3 right here. Now we want to simplify this because the whole idea is to write this as simplified as we can. And 3 times 3 is equal to 9, and then I'm left with square root of 3. And so then I know that I've used everything that's in here. So there we go. And this, if you wanted to check your work, 3 times 3 is 9, and then you could do 9 times 27. And if you wanted to check just to see, because it works the same way, you got 6. Sorry. Put my 6 in the wrong place. 9 times 7 is 63. Carry my 6. 2 times 9 is 18, plus 6 is 24. That's 243. Well, if I want to check this, 9 times 9 is 81. 81 times 3 is also 243. And I know it looks a little confusing with this already having a number outside the radical symbol, but it still works the same way. So this is your answer. It simplifies to 9 square root 3. All right, so let's try another one. Now this is using the product of quotients, and so if you remember, this is the same thing as saying square root of 9 over square root of 16. Well, these are nice perfect squares, so I can go ahead and find the square root of each of them. Square root of 9 is 3, and square root of 16 is 4. So all of this simplifies to 3/4. All right, this one we have square root of 27 over 15, so that's the same thing as square root of 27 over the square root of 15. This is now going to be like two separate problems, okay? And so we're going to have, so let's do square root of 27 first, okay? I have 27. 27 is equal to 3 times 9, just like we did already. 9 is equal to 3 times 3. So I circle it, I'm done. So that means this is equal to the square root of 3 times 3 times, kind of lost my multiplication sign, times 3. Down here we have 15, which is equal to 3 times 5. So that means underneath in the radicand, I'm going to have 3 times 5. It may not seem like it now, but this is going to help you in the end. We're really going to be able to simplify this a lot, okay? So I'm going to pull up top. I can pull out, since I have a pair of 3's here, you can only pull out matching pairs. I can still have one left. You have to have 2 to pull something out. So they're going to get married, move out of the house. So I've got a 3 outside, leaving me with a square root of 3. Well, on the bottom, this is the same thing as saying square root of 3 times square root of 5. Well, because I have something that is the same on the top and the bottom, they cancel out. Excuse me. I can cross out this square root of 3, and I can cross out this square root of 3, which leaves me with 3 over the square root of 5 on the bottom. So square root of 27 over 15 is equal to 3 over square root of 5.